When the photo service crashed, it became evident that troubleshooting was taking too long. The reason for the delay was tracked to log aggregation. The aggregated logs needed for troubleshooting were delayed. Worse, the more problems that are occurring in the system, the more log entries are generated and the longer it takes for the aggregated logs to become available for troubleshooting. Can you redesign the log system to eliminate the bottlenecks? Watch the lesson that describes the problem, then come up with your own solution. When you're ready, continue the lesson to see a sample solution. Remember that the sample solution is not the best possible solution, it's just an example, and your design might be better.
So now it's your turn. We're going to do our design challenge. We have to redesign for time. So here's what's going on. We've now created a cluster of web logs that also need to be processed. But the problem is troubleshooting is now becoming delayed due to lazy log aggregation. We're not getting these logs in time. We've got a daily cron job, and so we have to wait 24 hours before significant data. How are we supposed to maintain 46 minutes or less of downtime and troubleshoot if we can't really get up-to-date information? So now we have to think about this. So here's the challenge. Right, using, if you remember the 12-factor design, it says to treat log events as streams, so that should be a clue. The business issue is service resiliency. It's just taking too long to troubleshoot service issues. Batch processing of the logs just simply does not support live service troubleshooting. It's causing delays. We can't meet our service level objectives. We can't identify and respond to incidents and times. So here's the design challenge. Replace the cron batch processing with stream processing. And here's our hint, try to consider a microservices design. So I'm going to pause briefly here, so that way you can kind of mock up what you think your design might be, talk with other people in the room. But let's think about that. Okay, that's enough time. So we've identified the problem, right? Lazy log aggregation is impacting our SLOs. So you're going to design your solution, and here is our response. So this is only one solution. It may not be the best, but it's iterative. So now we decide to make the plunge, and we said, why don't we invest in a microservice architecture design? And again, we could still go to Dataflow, which is a fully managed service to do this. But Dataflow, our guy wants to stay away from Java, and so he's going to go to Node.js, right? So in this case here, we thought more from a microprocessing design, just to kind of keep it with the theme. We're going to ingest all of our messaging data to Google Cloud Pub Sub. The real benefit here is now we have control over queuing. If we overwhelm any particular service, we know that it's a resilient design. It's going to store log data for 7 days until we can transform it. So it does allow for real time if we can process it quick enough. So to do so, we decided to go with Cloud Functions. So very lightweight. It's going to be very affordable because we only pay for the amount of time the functions are actually being stored. It integrates very nicely with PubSub. Then we can push it back out to PubSub and create a published topic, so that way it'll be ingested inside of Bigtable. In fact, what we probably need is another function here that's going to be a writer, because I don't believe that PubSub will write directly to Bigtable. I believe that we'll need a subscription to actually pull it into Bigtable. I'll have to check on that. But again, these are the things you think about. You got to architect it, and then somebody who's actually going to implement it is going to tell you you're missing something. So that was kind of our process. And what we like about this is now we don't have to worry about clustering. We now have a scalable messaging queuing processing service, a scalable cloud function, microservices, and we now notice we've switched. So our business logic is still the same, but instead of a cron job, we now convert it to stream processing.